In order to find the Poisson's ratio and the new length of one of the sides of an aluminum block that has a rectangular cross section and it is subjected to an axial compressive force of 8 kilopound that causes 1.5-inch side to change its dimensions to 1.500132 inches, whereas the Young's modulus of aluminum is provided. In order to figure out our Poisson's ratio, let's go ahead and first write the definition of Poisson's ratio, that is equals to minus times the lateral strain over longitudinal strain. So first of all, let's go ahead and identify our longitudinal strain because of the compressive stresses that are acting on the block. So applying our Hooke's law, we know that stress is equals to Young's modulus times strain. Here the variable sigma is given as stress, where E is the Young's modulus and epsilon is the strain value. Now in this case, we know that stress is equals to force over cross-sectional area. So I can modify this formula and replace the value of stress to force over area. Now we know the value of force, and since it is in compression, we are taking the negative sign. So negative 8 kilopound divided by the cross-sectional area. Since we have a rectangular cross-sectional area, so 2 times 1.5 will give us the cross-sectional area of the block. That is equals to Young's modulus times the strain along the longitudinal direction, that is axis of the force in which it is being applied. Simplifying, we get our value of longitudinal strain as negative 0.00026667. Now, once we have identified the longitudinal strain, let's go ahead and figure out our lateral strain. That will be the change in length over the original length in the lateral dimension. So our original length in the lateral direction is 1.5 inch. However, the new length that is being changed is provided to us in the problem as 1.500132 inches. Taking a difference of these two numbers will give us a change in length divided by the original length of 1.5. Simplifying, we get our value of lateral strain as 0.000088. Now, once we have both of the strains, let's go ahead and plug it in the formula of Poisson's ratio and simplify. We are getting the value of Poisson's ratio as 0.33. Now, once we have the Poisson's ratio, let's go ahead and figure out the new length of 2-inch side. Now, since a compressive load is being applied on the block along the longitudinal direction, so in lateral direction, the block is going to expand. So our new length given by the variable h prime will be equals to original length plus the elongation that is happening in the lateral direction. So our expression of the new length will be equals to 2 plus lateral strain times the original length, since that gives us the elongation or change in the length. Simplifying, we get our value of new length as 2.000176 inch.